Hello everybody. Thank you for selecting this video. I hope you will enjoy the subject that I have presented to you today.
Okay, if we work with ObjectScript and want to use SQL statements, we have 4 variations. The first and probably best known is embedded SQL, where you put your SQL statement directly in your method or routine code, and the compiler translates it to some runnable code. This is a local use of an SQL statement, and when it's done you check SQL code. The next one is dynamic SQL. With dynamic SQL you create an SQL string and hand it over to a result set or SQL statement, process it and collect the results. The third variant is to use the terminal interface and run there $system SQL shell, and in this shell you key in your query and see immediately the effects and what is done. The fourth variant are class queries. These are queries that are based on static code structures inside your class. This variant is often used in system code, and we see 2 versions of it. There's the basic class query using %SQL query, which is more or less similar to the embedded SQL, except that you can present it also as SQL procedure and use it from outside, something that is not possible with the other 3 variations. The statement is straightforward and you have some local parameters that you can provide, as it acts like a class method. The 5th variant is the custom class query. It's the base of the basic class query and is totally open to you what you present with this query. This is often used in system code. For instance, if you have a query on all running processes, then the content of the output row is composed inside this custom class query, and you can display anything. You're not tied to globals or something else. You just create an SQL row one after the other until you say, okay, it's done and it is completed. And this is the core functionality that I want to present to you. For my demo I need, of course, some demo data, and we'll go to generated this with a simple class. You see it here. As the 3 very straightforward properties: strings, integer, and to make this example a little bit more sensible, a stream. This is the background is that streams are somehow not so easy handled inside ObjectScript. What you also see here is I've placed the parameter final to the class to have a narrow and easy to display global, and all the content will be generated using the populate utility. This is great, and you see you have last name, you have the limits for the integer, and that works fine, except for streams. Streams are not part of the populate feature, so I have to do it myself. And therefore we have here a method on populate, and if I run my method, my populate, you see as well I'm using parts of the populate facility and compose it, and for the sake of the final part I also insert a piece that I called line terminator. It's a separator, so the stream is split into pieces. Could be line terminator, could be named whatever you think. The point is every piece is separated and you can cross on it, and as I use the double pipe, you see it's going a little bit in the direction of HL7, where you have also all kind of separators. That is basically the separation inside the stream. Yes, and with this we run the populate utility. So for my demo I generate first just 8 records, which is enough to present the functionality using populate utility. And to make this a little bit more interesting, I remove one of the records to see if you jump over an ID. And finally, I also remove one of the streams to see how our query works if there is just no stream contained. Well, now let's take a look what was happening. So let's see what we have generated. We have global TUD with the data, TUS for the streams. And let's take a look. Okay, you see the records here and the reference to the stream. It's just the integer ID of the stream. So, and well, see, ID number 3 was deleted. Now we see the stream, and this is a typical stream, and you see the lengths. It's of course not really necessary to have a stream here, but stream is unlimited, and therefore it's important to have it here, though you might say, okay, we can do this as well with a long string. You're right, but that's not the practical experience. This is where we start, and let's step into the real customized queries. Now we are going to create a basic class query and to test it. We have here a class. I have prepared it already, named it TU0, and there is a wizard in Studio that allows me to add a query, as it is named here, into this class. I name it Q0, and we have to select if this is based on an SQL statement, a base class query, or based on a user-written code, which is the advanced version. We use this one, the basic version, and we have to provide some input parameter. I name it max rows. It's not a string, but it's an integer. Oop. Where is it? It's an integer. And well, we have a default value, and default is we display one line if we do nothing else. Okay. Next. And now, in the next step, we have to define what are the fields that we want to present. Well, we start with the ID. And we finish immediately as we want to get the framework, which is the most important part. Well, of course our table is not TU0, but it's TU, and we want to have age, we add age, city name, the stream, and what will we do with the max rows? We add a top close max rows. Well, and that's all the query. Of course, you can make this query much more complex. That's not the key point. The key point is that this query is just a normal select statement, nothing else. And in order to make it usable, also as stored procedure, I add the parameter SQL procedure. And an SQL name, and this is, I use Q0 as the name for a procedure. This is just a piece of comfort, otherwise you get the package in and the class name. This is the more handy version of the whole thing. I compile it. Well, and now let's take a look if you see it already. In Management Portal, now you see we have, I have the filter RCC. We have a table, yeah, with the well-known fields, and we also have now here a procedure Q0. That's great. Well, for visualization, I prefer to use the command line from terminal, the SQL shell, as it's easier to see and to present. So let's switch over to that. Now I'm going to present using the SQL shell. Well, I'll start it. and you can place your input here. Just to demonstrate how this works, I say select star from tu from rcc.tu. Well, and that's runs. You see our records there. That's nothing new, that's something you have seen already. The less attractive point is that streams are here not displayed by content, but it's just the stream OID that is presented here, which is programmatically it's attractive, but for visualization not really useful. And as our query is more or less the same, I can call it, as you remember, we have defined it as an SQL procedure. I can call it rcc.q0, and well, I want to see the first 4, and that's more or less the same result. Nothing great. Of course, you can use this stored procedure also like a table. So I have here a select statement. After the from, instead of the table, I have my stored procedure, since the stored procedure is displaying rows like a table. Gave it 99 as the maximum, so which means everything. And I have a condition, a where condition. For the processing, this means the stored procedure is processed first, and then the select is applied to this intermediate result. So let's have it. And you see, it works as if it was a table. Of course, you would say, why all this effort just to have something that is more or less could be done otherwise as well? And I agree with you. And therefore, we step to the next chapter with the custom query that provides, in our case, the content of the stream and not the stream OID. Our next chapter is the custom class query. It presents all the details, and you have control about everything that you want to display in your resulting row. I start this chapter with a new class named TU1, and again my wizard helps me to create this data structure, the query, and the new query is called Q1, just for ease of remembering, and this time it's based on user written code. So I go to next and enter all my call parameters. Okay, and instead of having a top, I want to have a range to set from one ID, from a start ID to an end ID, and I name it ID from it's an integer, oops, come on, an integer with a default value of 1, and I add an second call parameter id2, which is again an integer, and the default value for 0, which I intend to use if there is no 2, we run down to the end. And for the display of the stream, we do not want to have the whole, don't know how many characters of the stream, but a limited size. And this, I named this max text. It's again an integer, and I give it a default value of 25. Not to overload our display and wrapping rows, wrapping lines. That's not what I want to do. I go to next, and now we come to something new. We have to define how is the row that we want to display layouted. So, and a layout, we have an ID. It's you won't guess, it's integer again. It's integer, and you can add a caption to it. Well, there is not much practical use to me at the moment for this. We add the city, and that's a string, and I add we display the name, again a string, we display the age, once again an integer. You see, it's just some typing required. And finally, we want to have our stream. Okay. The shortened version of the stream. Here, the type is again string, and this would be in generally okay, except if we have very long strings, and therefore you see it in the example, you have to edit this piece afterwards. So, and what happened now is you got a header block, a descriptor with the input parameters, with a row spec, and row spec is exactly what we have typed in. I scroll it to the side, you see city a string, name a string, age a string, stream a string. This brings us to a critical point. ODBC typically wants to have a string size, and the default is 50. if you don't handle it and allow long var characters as streams do by default, then you have a problem. So we have to add this parameter for the external SQL type and for the unlimited length. Okay, let's do it. So we have to add these special parameters to our string, and you see it's getting a very, very long line with external stream type, long varchar, and the max length and unlimited maximum length. That's the default for streams in most ODBC implementations. So let's come back. Let's come back. What you see now, you have this header declaration that mainly creates the information for ODBC access. You have an execute method. This method is called at the first time your query starts. And the task of this execute method is to prepare running the output of your rows. The variable QHandle is marked as by reference, so it's from the external, from the query processor, handed over to execute, and it's used as a communication between the three class methods that build up a query, custom query. You have a close, that's the simple one, and you have the fetch class method that is called for every row that you want to output. And you get in the handle, of course, and you get the references for the row and a special variable at end. If at end is set to 1, then your query is done and the query processor knows, okay, there's nothing more to come. The row is a $list, as you see here, and it is processing containing the whole line. Now I have filled in a little bit of action. The execute is now initializing the QHandle, which in past was typically a local variable with subscripts. I tried a new approach to use it as JSON object, which works for easier reading, I hope, a little bit less quotes. Well, and you have to a list of parameters. You see ID from, this is the one that we get. ID2, that's the one that will signal the end situation. The max text, that's all that we have, all our core parameters, and some additional helping values like the actual ID, the actual object reference, and an actual stream reference to a stream object. Close is simple, just cleaning up. I killed QHandle and everything is over. If I scroll down to the fetch method is still empty. We will do this in the next step. First, let's compile it and see if it works. There are no errors. And at the moment, this query is almost ready, except a few things. We still have not added the flag for the SQL procedure and the SQL name, which I do now. SQL name Q1, asynchronous SQL procedure to be able to call it in an easy way. Okay, recompile it, and now the procedure is there, except that the row as such is an empty thing. The most important line for the fetch is this one. Set the row, which is the row variable, with the content that matches your row spec. So you start with the ID, we have the city, we have the name, we have the age, and the text we get from our stream. How to control this, like start row, end row, missing rows, missing streams. This is all contained in this routine. And well, seeing me typing is not a funny thing, so I provide you with the full content, but this is the main road, the main line of the whole procedure. Eventually now we're setting the end condition when you reach it. So, and I will now copy in this missing lines and try to explain it a little bit. It's quite a lot to do. It starts with initializing, finding out what is the maximum row ID. I'll do it here a little bit the dirty way. Well, and in practice, these queries would access the storing global directly. To make this exercise not too complicated, I do it in a less efficient way. I open the object, get for the content, which is definitely not what you might do in a normal case. It's just for the purpose of keeping this exercise readable. And once you have to, I open the stream and I keep the object reference and the stream ID inside my queue handle. This means at every time, for every row that I display, I have always the same object and the same stream object open. So there's no repeated opening of objects. This is the excuse. And then there are situations where there is no ID, there is no handle. Well, and then you have to start over and go for the next ID. So this is all done. As long as you're not at the end, you just write quit OK. And once reached the end, you set the variable at end to 1, quit OK, and your query is completed. Now let's see what all this code is producing. Now I return to my terminal command line, to my SQL shell, and call the new procedure. Q1, and give it a limit from 4 to 7, or let's start with 2 to 7. And this is the result. You see immediately ID 3 is skipped. There is no, it doesn't exist. So our limit from 2 to 7 jumps over this gap. And for the ID number 4, we have removed the stream. There is no output of a stream. So this is covered. Well, now we could make this the output length a little bit more. Let's say like 40. Okay. Now we have longer lines, but well, it's not really so impressive. So it would be attractive to have more of this stream, and not longer, but just more for better display. This will be the next query that I compose here to demonstrate it to you. The basic structure of the next exercise is pretty much the same. We see the class again, now named TU2. The query has 2, and we have a new call parameter, chunks. So you can pass now the number of chunks of the stream you want to see in sequence. There is not much influence to the execute. It takes over the call parameters, preserves them in QHandle, and all it has an additional internal field, the internal property chunk count, to count how many chunks you have processed already. Close is nothing important. And here we see more or less the same structure, except that it has an additional row loop structure inside, and the first row gets all the content like city name and so on, and all others just get the text of the new chunk. You have it in the examples, and you can try it. And as a next step, I want to show it to you how this is feeling if you process it. Well, I'll do it this time a little bit more easy, just starting at the first ID, running over everything, and getting 3 chunks, the three top chunks of our stream Well, and let's see. And that's the result. You have the chunk. The chunks get numbered 1 to 3. Well, if there isn't a chunk, there is no number. There's a number 1, yeah, but there's no content. And this runs through and you get all the pieces. In the last section you have seen that all the display power of your custom query is in the fetch method embedded. Well, you have seen I've displayed the pieces, the chunks of the stream in sequence, and to show a little bit more what is possible, I decided to take something new in, a functionality that you know from strings. For strings you have a $piece function, and you have a separator. You can pick out exactly that piece that you want to see. This does not exist for streams. Well, if you convert your stream into a string and they're small enough, this could be a solution. But in fact, directly in a stream, unlimited by any size of your stream or your string, does not exist. So I decided to take an approach that allows you to say, I want to see exactly piece number 7 to 8 or something similar of my stream that is separated by something, and this something I took the double pipe, and it was all inspired by seeing HL7 streams separated by cut it in pieces by various separators. So this was the basic idea, and that I intended to show it to you, since it's possible to do it directly from stream with almost no effort, and well, as a practical use of a custom query, since with SQL, with pure SQL, you have no chance just to get these parts out. I'll skip all the typing and brought in the ready prepared class. First, it starts with the fact you have, it looks in the beginning rather similar to the previous examples. You have the maximum size of the chunks you want to see, and now you have a separator that is by default a comma, as we know from $piece, a start piece, an end piece, and a parameter grouped by. Grouped by is meant to have, if you have small pieces, you can put 2, 3 more pieces into a single line of display, which made sense. In addition, I have added a parameter before. This is based on practical experience, since I quite often met the situation that I have pieces also in a string, but I would like to know what was just the thing, the last before me. And well, it was possible. So, but here it was just a chance to use it by the way that the stream is accessed. Here you see the method execute that does the initialization, and you see the number of properties in my JSON object has grown significantly, as you need a group, and if you are in the group you have to find where you are, and if you are at the end, and so on and so on. So it's significantly longer, and well, as I'm lazy typing, I say, hey, there's no need to name it QHandle. It's all over the documentation, it's always named QHandle, and of course it's just any name. It's an object or a subscripted local variable, doesn't matter. The key point is that it survives over all the process, from initialization over all the rows that you display until the end. So we go ahead. Well, close is rather easy, and the rest looks more or less similar. The key point at that fetch method is the processing of the pieces, and there I have my own class method added named piece. Well, not really creative, but easy to remember. And piece now goes into the stream, has to know exactly where the stream starts, where it ends, has to know how many pieces it contains. This is the first action overall. The first action, I run over it and create a list with the information where the pieces start, just as more or less the same way that the $p is implemented for strings. And once it is calculated what you really have to take out of the stream, then the stream offers a very useful function named read SQL start stop. It doesn't sound very extraordinary, but it is very sensitive. If either start or stop points outside your stream, you just get nothing. So all the things before you have just to do to make sure that you're not running out of the stream and just get rubbish content. The whole class is part of the distribution, part of the example, and the query in this case is the query number 3Q3. All the rest is looking quite similar, except this piece function that makes it possible to find the pieces. Since as you re-enter it for every line, you have to initialize it, except for the positions, for the individual search again and again. Now I've returned to my SQL shell and call the procedure number 3, and you see the list of input parameters has grown quite significant to cover all the possible variations, and in clear text it would say, well, we want to show the objects number 1 to 5, here, with a length of maximum output length of 33 characters, separated by double pipe, want to see the pieces 2 to 4, grouped by 2 by line, with 3 previous characters. Well, it's long, but you will see what it does. You see row 5, rows objects 1 to 5 that have a maximum of 52 pieces, and they start as demanded with piece number 2. This is this one, with a prefix of 3 characters. This is here, and with 2 pieces by row. So next row, the piece count of this row is just 2, and you see it here on the right. As the next, you have the same, again with a prefix. So it's real everything covering approach. It's questionable, of course, if you need them all together. Most likely you will need one or the other. This is more the demo version to show it is possible. So, and there's still another example. Well, it says all records from 5 to end. We have no termination ID. At the length of 32, we separated double pipe, starting with piece 50 to 55. Remember, we have just 52. So this was my personal test. First, how do I treat with this query if there are no pieces anymore? And as $piece for strings, if there is no piece, there should be no output. And this time, 1 piece by line. Okay. Yeah, and that's it. You get the pieces line by line. Well, some wrapping that is less attractive, and do it. Probably do it again. So, yeah, it's cut off in the video, but anyhow, you see it's exactly line by line displaying from it goes. And this was my personal helper. At the end, I always was writing in done to know I'm at the end. Well, and this is using this read SQL that is part of the stream, of the global character stream, and there was quite an interesting point to detect. So now you have seen the whole tutorial.
Okay, this was the video. I hope you enjoyed it. I hope it was interesting to you, and I hope you will see me again with my next video on this channel. Goodbye.